Okay, we're going to shift gears now. We've been working a lot with square roots. Now we're going to go into what we call the principal nth root. So go ahead and pause and read. Okay, the definition of a principal nth root. So far we're talking about square roots. What if we change the index, this little number right here? We can go ahead and simplify it, but we're looking for what that index is in pairs. So here's an example. The cubed root of 64 equals 4. The reason why is I'll separate this out. 64 can be broken down to 4 times 4 times 4, or 4 cubed. So what I tell my students to do, look at the index, cube root. Look at the power, cube. If those numbers match up, everything cancels out, and you're left with that base of 4. So here's a second example. The fifth root of negative 32. Break it down. Negative 32 can be written as negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which gives you 32. So that's negative 2 raised to the fifth power. The index and the power match up, so you're left with an answer of negative 2. All right, next one. Go ahead and pause. A perfect nth root. If you have that power and index that match up, you're left with an A, whatever that is. If it is even, then you have to take the absolute value of it. So again, if the index is odd, you're fine. If your index is even, you take the absolute value of it. So there's a couple examples down below here. So index is odd, index and power match up, so you're left with negative 2. All right. Index is even, index and power match up, negative 2. Take the absolute value of negative 2, absolute value of negative 2 is 2. So be careful on these. This is when you have a perfect nth root power. Look at seeing if you have an index that's either even or odd. All right, going on to product and quotient rules for nth roots. So we've already spent some time working with square roots and multiplying and dividing those. If my index is the same here and here, you can combine them back together or separate them out. So here's how it's separated out. Nth root of A, nth root of B. They can combine back together underneath one radical. Same thing happens true with a quotient. Here is your index. You can separate it out into two separate radicals. Or vice versa. You have two radicals with the nth root, same root, you can combine them back in together one fraction. So we'll do some practice problems here. All right, cubed root of 24. We want to simplify the cubed root of 24. So we're looking for groups of 3. So we say, all right, let's break down 24. 24 can be a product of 8 and 3. 8 times 3 is 24. Now we're looking for a power of 3. So I think about 8. Well, 8 can be broken down as 2 times 2 times 2, which is 8. All right. Now, you may want to separate this out like this. Cube root of 2 cube root of 3. Now, the rule is index and power must match up, so that reduces down to 2. This one has a power of 1, so that has to stay as it is. So that's going to be cube root of 3. So it's 2 cube root of 3. All right, example B. We have 4th root of 8 times 4th root of 4. Notice the indexes are both the same. They both have an index of 4, so you can combine these two radicals together. So 4th root, now 8 and 4 multiply together. Now we're going to go ahead and try and break this down. So I'm looking for a power of 4 underneath. So 8 can be broken down to 4 times 2 And then 4 can be broken down as 2 times 2. We're almost there. Now let's say 4 can be broken down to 2 times 2. And then we still have these other 3 2's here. All right, I'm going to regroup. These guys are all going together. It's 2 to the 4th. And I have this lonely 2 over here. All right, now I'm going to separate out 4th root of 2 to the 4th times 4th root of 2. Notice the index and the power match up, so that's a perfect root. So that reduces down to 2. This one does not have a group of 4, so that stays underneath as 4th root of 2. All right, let's go ahead and bring this down a little bit. Next example, 4th root of 81/16. We can go ahead and separate this out as 4th root of 81, 4th root of 16. Now let's see if we can simplify that. We're looking for a perfect root. So I'm going to say, all right, 81 can be written as 9 times 9, and 16 can be written as 4 and 4. Break it down farther. 9 is 3 times 3, 3 times 3. Denominator, 4 and 4 can be broken down to 2, 2, 2, 2. All right. So now, look at, we have a group of 4 here. That's 4th root of 3 to the 4th. Index, power, match up. Awesome. Now notice this index is even. If I take the absolute value of it, it's still just going to be 3. Denominator, 4th root. Group back together that 2 to the 4th. Index, power match up, awesome. It's a perfect root to give us 3 halves. I think I'll stop there.